Hello everyone, this is Jay and I'm here to give you a recording and tutorial on how we subtract polynomials. There's two different ways. One is called the horizontal method, the other is the vertical method. Either method is fine. I think you will find they're very similar, and as long as you are careful with your signs and applying the subtraction principle correctly, either method will work. Okay, let's look at this example. We have 3x minus 5 minus the quantity of 6x minus 4. Now, when we subtract, the important thing to do is realize that the polynomial we're subtracting, 6x minus 4, we have to subtract both terms that are in those parentheses. And I'll show you what I mean by that. When we go to do the subtraction, we have to change the signs of the second polynomial. That's how we do that. And we change the minus sign to a plus. So what we're going to do is, instead of having minus the quantity of 6x minus 4, we're going to change that to plus. And when we change it to plus, in front of the 6x, we put a minus. And in front of the minus 4, we change it to plus. So see, what we essentially did is distribute it. That's called distributing the negative sign. So we changed the minus to a plus and then change the signs of both terms in the parentheses. Now, once we've done that, it essentially becomes an addition problem, and we add the like terms. So 3x plus a negative 6x, being careful with our signs, we should get negative 3x. And then minus 5 plus 4, we will get a negative 1. And the reason it's negative 1 is, think of the minus 5 being larger, and the 5 is larger, it's negative, and we add 4, so we end up getting minus 1. So negative 3x minus 1, that's our final answer. Let's look at another example. Here we're going to subtract y cubed plus 4y squared minus 2, and we're going to subtract that from 7y cubed plus 8. So even though it's in words, when we see the word subtract something from something else, you got to be careful with the order. What that translates to is 7y cubed plus 8 minus the first polynomial, which is y cubed plus 4y squared minus 2. That's how we write the problem. Once we've written the problem, we change the minus to a plus and change all the signs in the parentheses. So see where we had a y cubed, it became a minus y to the third. We had a plus 4y squared, it became a minus 4y squared. And the same with the minus 2 became a plus 2. Now we can combine like terms. 7y cubed plus negative y cubed, we get 6y cubed. The minus 4y squared term, there's no other like terms to combine that one with. So we just leave it in our problem, in our answer. We don't do anything else with it. And then we have two numeric terms, 8 plus 2. We can add those, and when we do, we get 10. So 6y cubed minus 4y squared plus 10 is our final answer for that problem. Okay, we've done two examples involving polynomial subtraction using the horizontal method. Now let's do one using the vertical method. For the vertical method, as you might guess, what we do is we align the terms. And when we align the terms, we have to make sure we're aligning the like terms. So we arrange the terms in columns, make sure we have the largest exponents coming first on the left side, each term, and we show the subtraction. Now take the second row, the polynomial that we're subtracting, and change all the signs. So like we have a minus 6g to the fourth. We have to change that to a plus 6g to the fourth. The 2g cubed becomes a minus 2g cubed. Minus 4g becomes a 4g, and you get the idea. Now at this point, we're ready to add the terms. So let's do that. 4 plus 6, we get 10g to the fourth power. Minus 5 minus 3, we get minus 8. Minus g plus 4g, we get 3g. We have to be careful with our signs. 6g plus a negative 2g cubed, we get 4g cubed. And then 4g to the fourth plus 6g to the fourth, we get 10g to the fourth power. And that's our final answer for this problem. I hope this was helpful. If you do find the video helpful, please subscribe to my channel and watch some of the other videos I have on working with polynomials. Thanks, and again, this is Jay from Jay's Math Gymnasium.